Hi, welcome to another topic in digital logic design. Our objective today is that when we get done with this video, or probably a series of videos, we're going to have a clear idea of what it means to instantiate a Verilog module. What I've got in front of me is I've got a circuit schematic. We're going to work from physical schematics. We're going to look at the schematics, the block symbols, and we're going to relate that back to how we create the same sort of connections by writing Verilog modules and instantiating those modules. So what you see on the screen in front of you right now is a schematic for a function that's the output f is equal to a and with b or with c, right? And so in the schematic, you can see we have an output pin. It's been named f. We have three inputs to this circuit, a, b, and c, right? The circuit consists of an AND gate and an OR gate. Right. What we want to do is we want to use this circuit in another circuit. And we don't want to have to recopy it and use it in a lot of other places because we want to design this circuit, this special purpose circuit. We want to design it, define it in its own space, and then we're going to create a block symbol so that we can use it in another, elsewhere in our design, sorry. So file, create, update, create symbol files for current file. By default, it just uses the name of the file, circuit 1 BSF block symbol file, created it. If there had been syntax errors, it would have told us about those. And so now what we want to do in order to use this, we've got another blank schematic here. What we do is we simply go to the insert symbol, right? And when you create your own symbols, you will find them in your project folder. So there's the symbol it created. We add it to the schematic. And so this encapsulates the behavior of this. We've just basically created some sort of building block, right? A symbolic block that means whenever we use this, basically what it's going to do is it's going to insert a circuit like this in our design. We just don't have to redraw that circuit. It gives us the same behavior. Right. And so you can see when it creates a block symbol, it uses the input and output names of this circuit back here, the three inputs A, B, and C, the output F. And by default, the inputs are shown on the left-hand side of the symbol, the outputs are on the right side of the symbol. Right, so now in our circuit, let's just assume that we are going to connect this. We want to download this to the development board, right? And this development board we have has slider switches. So we're going to connect switches 2, 1, and 0, right, to A, B, and C as our inputs. So schematically, if I want to add inputs, I'm going to grab input pins. I'm going to need 3 inputs, and I'm going to need 1 output to connect to the symbol. All right, and I can wire these in. So I'm going to make these connections before we name things. All right. And so now I'm going to double click on this. And so my hardware name is going to be, I'm going to connect switch 2 to A. I'm going to connect switch 1 to B, switch 0 to C, right? And typically in the courses I teach where I'm working right now, we work with Altera or development board, right? Which specifies that the switches have to be all caps SW, right? And we put in brackets here the switch number that we want to use. So this is the syntax that is defined by the manufacturer of the board. And we want to output this to a red LED. And that is specified as all caps LED R. And let's say our circuit output is just going to show up on red LED 0. So that's how we define that circuit. Okay. And so now we have another circuit. I've not saved it, so let's save it. File, save, and I'm just going to call this circuit 2, right? And so our circuit 2 has an instance. Notice when I put this block symbol in here, down in the corner, there's INST, right? Everything has a unique instance name. And so this one is called inst. If you even go back to right here where I use quarters to insert the logic gates, well, it gave the AND gate its unique instance, inst. It gave the OR gate, inst2. So our gates, our symbols, our circuits are given instance numbers, right? Because there's actually a hardware description language, even though we use these gate symbols, it's actually a hardware description language running in the background that creates our circuits, right? And so everything has to be instantiated, right? So now, if I just said, let's make this our top level design, I'm going to make this file top level entity, and I just want to run analysis and synthesis on this, right, to see if I had any connection errors, any naming errors, and this should be fine. All right, so no issues. All right, so we've created another circuit, right? If I had the development board here, right, I could go through the steps of downloading this to the board and playing with the physical switches and the red LED. That's not what we're doing here today. What we want to do is we want to think of this as its own circuit. As a matter of fact, we could say file, create symbol files for current file. It would make one for circuit 2. We've got another block symbol. If we needed to use this elsewhere, we could create a new schematic. Right. We could insert that symbol. So this is the one's called circuit 2. And when we insert that symbol here, right, let me make that bigger so you can see it, right? That encapsulates the behavior of this circuit. And within this circuit, right, it had an instance of circuit 1, right, which encapsulates this behavior. Right. We don't really need to use this at this point in a block schematic, but we could. Right. We could make other connections here. We might have multiples of these in a circuit schematic. We'll see some more advanced examples of that in the next tutorial. But for right now, let's go back to the idea of how do we do this in Verilog. So I've also created a Verilog file that implements the very same behavior as our circuit 1 schematic, right? Notice we've got an output. So our port list consists of A, B, C, and F. And here I've defined F as the output, right? A, B, and C are the inputs, right? They're all single bits, right? Because I haven't defined a bus size, right? Here is our Verilog assigned to F, A ANDed with B, and that quantity ORed with C. That is the very same circuit as what was drawn schematically here. I simply named this one circuit 1V for Verilog. Well, if I wanted to, I could create a block symbol from the Verilog file. I could say file, create, update, create symbol files for current file. Now I don't want to save changes to that other block. All right, and I think that was successful. See the menu pop up. So if I go to insert symbol, notice now we have a symbol for circuit 1V. That's our Verilog. And let's insert another, so let's insert symbol, circuit 1. This was the symbol we created for that block schematic. Right. Notice they look the same, right? They both have the same inputs, the same output. They were both defined to act in the same way, right? The logic is A ANDed with B ORed with C, right? So physically, right, you could make a symbol out of your Verilog circuit in the same way you can make a symbol out of your block schematics. But what we want to do is we want to learn how to instantiate this in another Verilog module. So in the same way we created the block symbol circuit, circuit 2, let's create a new module. And so file, new, Verilog HDL, say circuit 2 instantiates circuit 1V, and we're going to connect switch 2. So we're going to connect circuit 2's switch 2 to circuit 1V, circuit 1VA. I'm going to do a copy paste here. Circuit 2's switch 1 to circuit 1VB. C and switch 0. I lost that. All right, to circuit 1BC. So back here in circuit 2, right, in the schematic, right, we connected switch 2 to circuit 1. So circuit 2, switch 2 to circuit 1A, circuit 2, switch 1 to B, switch 0 to C. So in our module here, right, I'm going to call this circuit 2V for Verilog. We're going to have input switch W, switch 1. I'm going to show you how to do this with a bus next. So for those of you that know how to do this with a bus, that's great. LED R. Yeah. LED R0. Actually, I think for the I know for the Altera hardware that doesn't quite work, so we actually have to do this. SW for switch, LEDR for red LED, and here input wire. I want to use the 3 switches, 2 down to 0. Do this correctly. Output wire, I'm going to only use one red LED, LEDR 0, so the syntax has to be 0 down to 0. And so we don't say 0:0, we say right, 0 down to 0. 2:0 is 2 down to 0, typically what we say, LEDR. All right, so we've defined our inputs as 3 different switches, our outputs as, right, one of the red LEDs. So now in order to instantiate that module, what I like to do is I like to either copy over the port list. I've got this in another file here. So there's a comment right now, right? We'll copy this over. So we're going to, so named, right? Instantiation of module circuit 1V. Whenever we instantiate a module, we have to use the module's name, right? We have to tell it what circuit we want to use. Then way back here, right, sorry, in this block schematic, notice how this had the name circuit 1, right? The name we gave the symbol of our circuit 1 here. So because this is called circuit 1V, right, over here, in order to use that module, I have to use the name circuit 1V. It has to know what circuit I'm talking about. I need to give it some unique instance name or number. Maybe I'm just gonna, it doesn't have to be spelled INST. You could name this anything as long as you follow the Verilog identifier naming rules. But typically, especially getting started, we use INST to remind ourselves this is an instance. And then what we need to do is we need to specify how do we want to make our port list connections, right? Back here in the schematic, right, we had this symbol and we needed to know, well, inside here, circuit 1's A, what do we connect to circuit 1's A? We connected switch 2. So named instantiation means that I name the signal in the module I'm instantiating. So the module we're instantiating is circuit 1V. I name one of its signals. I have to use the period, and then I use the name of one of its signals. Well, I'm going to start with A. You don't have to go in order of the port list. That's the idea behind named instantiation. Is I'm specifically going to say, I want to connect to circuit 1V's A. What I want to connect is, in this module, I want to connect switch 2. So I can refer to SW2 with a syntax, right? It goes in parentheses. So this is the name of the signal within the module I'm writing that I want to connect to the module I'm instantiating. And I want to connect then to circuit 1V. I want to connect to B. I want to connect my switch 1. And to C, so dot C, I want to connect switch 0. And then to the output F, I want to connect LED R0. And this is how we instantiate a module. We use the module's name. We have to give it some unique instance name. And then here in my port list, named instantiation means I name the signal in the module I'm instantiating. So dot A, that's the name of the signal A in circuit 1V. I name that, and then within parentheses, I say, well, what here in my local module I'm creating, what do I want to connect to A, right? What do I want to wire here locally to B? So circuit 2V, its signal is switch 1. I want to wire that to C. Here in circuit 2, switch 0, I want to wire then to circuit 1, circuit 1C. I want to wire my LED, my red LED, here in this module to circuit 1's F, right? Which looks symbolically then looks just like this, right? Here are the input switches to switch 2 is wired to A, switch 1 is wired to B, switch 0 is wired to C, red LED 0 is wired to F. Right? We've done the same thing here, we've just done it with a hardware description language. And we have to end our module, end module. All right. So that's how we instantiate something with named instantiation. Right. I prefer to use named instantiation because I very specifically say, what signal here in the module I'm creating am I connecting to this module that we're instantiating? So by using the name of the module and instance number, specifying the port list connections, we've done the same thing as inserting this block symbol and connecting these input and output pins to it. We know which is an input here locally in this module simply because we defined our input. We defined our signals with the descriptors input and output. And let's see, I could save this. Right. Let me save it. And circuit 2V. Right. I could create a block symbol out of this if I wanted to. File, create update, create symbol files for current file. No, I don't want to save changes to block 3. All right, so down below it tells me it was successful. All right. So remember how we created the circuit 2 symbol. So I'm going to say insert symbol. And from that schematic, we created that circuit 2 symbol. Right? So that was created from this, right, schematic. Well, we just made a symbol of our Verilog, so insert that, right? Circuit 2V looks just slightly different, simply because we defined the switches as a bus. So we have a thicker line here that indicates a bus, multiple wires. Right, same way on the red LED, 0 down to 0 in the output, right? Even though there's only one wire in there, because it's 0 down to 0, we have a slightly thicker line. They're both the very same circuit. They will give you the very same behavior. Right? It's just getting used to the Verilog syntax, because we don't necessarily have a picture in front of us. A lot of times when I design systems, I just on a sheet of paper I just write my block symbols. I'll create a system and I'll use block symbols. I'll draw wires from one to the other so I can have an idea of how I want to wire these together. And of course, the longer I work, the more I can see it in my head, and I don't have to do that. But I find a lot of times, to make sure that I'm connecting things correctly, especially if I'm getting tired, drawing a picture always helps. Right? So hopefully now you have a better idea of how to instantiate a module. Right? And students usually start right with these single bit inputs, right, and outputs. But what we want to think about is, what do we need to do when we have a bus? So let's actually then take a look in the next tutorial at what we do when we have a bus with this circuit. We're going to stop this here, and in part 2 we'll go on with buses. All right, thanks for watching. Questions, let me know. Post questions in the comments if you're watching this on YouTube. If you're in my class, obviously hit me up for office hours, email, or in class. All right, practice this. You have to get good at it. Practice makes perfect.